One, we're going to start by naming a pair of corresponding angles. So corresponding angles are the angles that correspond with one another. So an example of that would be angle 3 and angle 7, because angle 3 is above the parallel line and to the right of the transversal. Angle 7 is also above the parallel line and to the right of the transversal. So angle 3 and angle 7 would be a pair of corresponding angles. Then alternate interior angles, those are going to be on opposite sides of the transversal on the interior of the parallel lines. So angle 6 and angle 4 would be an example of that. And then alternate exterior angles are going to be on alternating sides of the transversal on the exterior outside of the parallel lines. So an example would be angle 2 and angle 8. So I'm going to write that down, angle 2 and angle 8. And then same side interior angles. Same side interior angles can also be called consecutive interior angles. So those are going to be on the same side of the transversal on the interior of the parallel lines. So an example of consecutive interior angles would be angle 7 and angle 4. So that right here, again, I know a lot of kids have trouble with this one. Same side of the transversal inside of the parallel lines, angle 7 and angle 4. Number 2, we're going to find the slope of the line that passes through the points 1, -4 and 3, -5. So to do that, we're going to be using the slope formula. My slope is equal to y2 minus y sub 1 over x2 minus x sub 1. So what I'm going to do is I'm going to go ahead and label these points so that I can plug them into my formula, x1, y1, and x2, y2, and I'm going to plug those numbers in. So y2 is -5 minus y1, so minus -4, and x2 is 3 minus x1, which is 1. And then on the top, we're going to know that when I have two negatives, it becomes positive. So it's actually -5 plus 4, which is -1, and 3 minus 1 is 2. So the slope of the line that passes through these points is -1/2. We're going to identify the slope of a line that is perpendicular to the line above. And then, so we need to remember that perpendicular means the slopes are opposite reciprocals of one another. So an opposite reciprocal means that we're going to change the sign. So this is going to become positive, and then the reciprocal means we're going to flip the fraction. So my new slope, again, change the sign. For opposite, it's going to be positive, and the reciprocal of 1/2, if you flip the fraction, becomes 2 over 1, which is the same thing as just saying my slope is 2 for the perpendicular to this slope up here. Number 3, we're going to be given that line P is parallel to line Q, and they're intersected by this transversal T, so we're going to solve for x. Given the information that these are parallel lines, we are able to use our theorems, which we talked about a little bit over here in number 1. So based on what we did in number 1, we have to memorize that these are called same side or consecutive interior angles. So since they are consecutive interior angles, we have to memorize that those are supplementary. So that means that we are going to add these and we're going to equal them to 180 degrees to set up our equation. So 4x plus 90 plus x plus 15 is equal to 180 degrees. So now I'm going to combine like terms. 4x and x is 5x. 90 plus 15 is 105. That's equal to 180. And then I solve for x by subtracting 105. So 5x is equal to 75. And then dividing both sides by 5. 75 divided by 5 is 15. But I will show those steps using the long division. 5 goes into 7 once. 1 times 5 is 5. Subtracting 25 divided by 5 is 5. 5 times 5 is 25. So no remainder. My answer is x equals 15. Number 4, we're going to consider these angles formed by the lines. We're going to write an equation that can be used to solve for x. So, and then we're going to solve. So we have actually a few equations that we can come up with from here. So one equation I'm going to look at first would be if I looked at these two. So this angle here and this angle, these two angles form a line. So these two angle measures are going to add up to 180 degrees because this is a linear pair. So I'm going to write that down. These angles form a line, meaning these angles are a linear pair. So I'm going to add those angle measures and set them equal to 180. So I'm going to combine like terms. 9 plus 2x is 11x. Then to solve, I'm going to subtract 15 to both sides. So 11x is equal to 165. Then dividing both sides by 11. 165 divided by 11. 11 goes into 16 one time. 1 times 11 is 11. Subtract and bring down. 55 divided by 11 is 5. Multiplying, no remainder. So x is equal to 15. So that is one equation we can get from this figure. We're going to write another equation. So using two other angles, we're going to write an equation to solve for x. So I'm going to go ahead and look at vertical angles. I have 9x and 6x plus 45. Those angles are vertical, and we know that vertical angles are congruent. So I can set up my equation that way. So I'm going to set that up as 9x is equal to 6x plus 45. Because they're vertical, they're congruent. So then I solve by moving the 6x to the other side. And then dividing by 3. X is equal to 15. And then I'm going to go ahead and show that work. No remainder. So x equals 15. And you should get x equaling the same number in this problem. Number 5, they're giving us a design for a rectangular flag, and the corners are labeled A, B, C, and D. The horizontal edges are parallel, so we have A, B, and C, D are parallel, and the vertical edges, A, C, and B, D, are also vertical to one another. Or, I'm sorry, yeah, vertical. So they're parallel. Let's write that down. Sorry, I'm not making any sense right now. Let me recollect my thoughts. Okay, so we know these two are parallel, these two are parallel. And then they're giving us that the measure of BAD, so BAD is this angle here. We'll go ahead and write in 8x minus 15 degrees for that angle measure. And then CDA talks about this angle, is 5x plus 15 degrees. So they want us to find the value of x and write the reason for making that equation. So I'm going to go ahead and extend this line. So we have our parallel lines that are happening, and then this we will consider to be our transversal. That's going through our parallel lines. So I'm just going to extend that a little bit so we can see it visually a little bit better. So based on these being parallel lines and this as our transversal, I'll go ahead and highlight these parallel lines. Since these are parallel and the blue here is our transversal, we have alternate interior angles. So I'm using alternate interior angles to create my equation between these two. They're on alternating sides of the transversal and on the inside of the parallel lines. So alternate interior angles we know are congruent. So I'm going to set up my equation by setting these angle measures equal to one another. And then I'm going to solve. So I'm going to subtract 5x to both sides. 3x minus 15 equals 15. Add 15. I have 3x is equal to 30. Dividing by 3. 30 divided by 3 is 10. So x equals 10. And then in part B, they want me to find the measure of angle BAD and the measure of angle CDE. So the measure of angle BAD we'll do first. I'm going to write kind of small here. So the measure of BAD, again, is given to us up here, 8x minus 15. So I'm going to write that down, 8x minus 15. And then I'm going to replace x with 10 since we found and solved for x. So 8 times 10 minus 15 when I replace x with 10. And that's going to be 80 minus 15. 80 minus 15 is 65 degrees. So the measure of angle BAD is 65 degrees. And then we're going to look at the measure of angle CDA. So the measure of angle CDA was given to us up here. CDA is 5x plus 15. So I'm going to write that down. 5x plus 15. And I'm going to, again, replace x with 10. That's 50 plus 15, and we get 65 degrees. So these are going to be the same equal measure because these are alternate interior angles, which are the same angle measure. So we technically just had to plug in here, and then we knew they were both 65, but it's a good idea to just show your work for both to double check. All right, number 6, write the equation of the line that is parallel to this y equals negative 4/3 x plus 6, passing through the point negative 7, comma 2. So when we write in a parallel line, an equation of a parallel line, we have to remember that parallel lines have the same slope. So in my new line, my new equation, I'm going to use this negative 4/3 as my slope because we remember the slope is the number in front of x. So for my new equation, I will be using m equals negative 4/3 because it has to have the same slope since these are parallel lines. They want me to write the equation in point slope form. So I'm going to write that equation down. Y minus y1 is equal to m for my slope times the quantity x minus x sub 1. So that is what they want us to use for our new equation. So given the slope m, we're going to plug that in right here for m. And then they give me this ordered pair that we're going to pass through, x sub 1, y sub 1. I'm going to label it like that, and I'm going to be plugging that in right here. Those numbers will go for y sub 1 and x sub 1. So you always copy your first y. Then you replace y1 with y1 here from your ordered pair. So that's minus 2. That's equal to my slope, which is negative 4/3. Open parentheses. Copy your first x, and you're replacing x sub 1 with x sub 1 from your ordered pair, but since it's minus in my formula, I'm going to write plus. So this is going to be our answer. They just want the equation in point slope form, so leave it in point slope form. I'm going to talk a little bit about this some more, that when you plug in negative 7 here, and when you plug in 2 here, because of our formula having negative in front of these points, you are essentially just changing their signs when you plug it in. So the 2 became -2, and the -7 became +7. And then of course, we just plugged in our slope right here. All right, number 7, they're giving us that QRST is a square, and then they tell us the equation of line RS. So here's RS. That equation is y equals -x plus 7. And they want us to find the equation of ST. So we're going to be looking for the equation of this line right here, given that t is at 1, -2. So we're looking for the equation of that line. All right, so since this is a square, squares have these opposite sides that are parallel, and they also have their corners here. These are going to be perpendicular. So the lines intersect, forming a 90-degree angle. So since these lines are perpendicular, I know that my slope for this line that I'm going to create, this equation, has to be the opposite reciprocal of this line up here. So again, I'm going to use this rule that says perpendicular lines, their slopes are opposite reciprocals. So my slope over here, up above, the slope is -1, which is the same thing as -1/1. So when I create my new slope, I'm going to change the sign, so it's going to become +1, and then flip the fraction so it stays as 1/1, which is 1. So my slope that I'm going to use is +1 for my equation right here. So I'll use m is equal to 1, and then I'm going to use my ordered pair, x1, y1, because this line is passing through this point. So using these 3 numbers, I will use my point slope formula and plug in. So the first y, again, just copy down. y1 from my ordered pair is -2, so I'm writing +2. That's equal to my slope of 1. Copy down your first x, and x sub 1 is 1, so I write -1. So I want to write the equation in slope-intercept form, so I'm going to get rid of parentheses by distributing. Y plus 2 is equal to 1 times x, which is just x, and 1 times -1, which is -1. And then to get y by itself, we subtract 2 to both sides. So the equation of my line is y is equal to x minus 3. Number 8, we're given that line P is parallel to line Q, and they're intersected again by a transversal, so we're going to find x. So that'll be part 1, find x. Since they're giving us that these are parallel lines, again, we have our 4 theorems that come into play, the corresponding, alternate interior, alternate exterior, and same side interior. So based on these 2, they're giving us the measures of our alternate exterior angles. So since these are alternate exterior angles, the theorem says that these are congruent. So when I set up my equation, I set these equal to one another. So it's going to be x plus 15 is equal to 4x minus 60. And this is going to be part 1 where we find x. So to do that, I'm going to subtract 4x to the other side. 1 minus 4, that's going to give me -3x. And we're going to bring down the rest. Then I move over the 15 by subtracting 15. Same sign, add, keep the sign, gives us -75. Then I divide both sides by -3. 2 negatives when we're dividing will give us positive. 75 divided by 3, x equals 25. That's going to be part 1. Part 2 says we're going to find the measure of the acute angle. So the acute angle is going to be the angle less than 90, which is the angles that were already given here. So I'm going to go ahead and use this angle measure, x plus 15. And then I'm going to plug in x is 25. So 25 plus 15 is 40 degrees. My acute angle measure is 40 degrees. Again, you could have used 4x minus 60 and plugged in x here, but I thought using this equation would be a bit easier for us since we just had to add 15. Number 9, we're given this diagram and we're going to name the pair of segments that are perpendicular. And there that word is again perpendicular. We know perpendicular lines form a right angle. They intersect at 90 degrees. Or if we look at their slopes are opposite reciprocals. So what I'm going to do is I'm going to find the slope of each of these 1, 2, 3, 4, 5 segments, and I'm looking for the segments that are opposite reciprocals of one another. So I'm going to start with RP, and I'm going to calculate the slope of that. So the slope here is going to be rise over run. So I'm going to start and I'm going to go down 1, 2, 3, 4. So a rise of -4, run of 3. So my slope for this line is -4 over 3. Okay, now let's look at segment PS. So segment PS right here, we're going to calculate rise over run. So again, I'm going to count 1, 2, 3, 4. So down 4 and over 3. So my slope here is -4/3 again. All right, so then I'm looking at this line T, and I'm going to calculate the slope for that one. That is going to be, let's go this way. We're going to rise 1, 2, 3, 4, and run 1, 2, 3. So this slope is +4/3, counting the boxes. And just because one's negative and one's positive, we can't say that these are perpendicular because we want this fraction to also be flipped because opposite reciprocals. So that is not going to be our answer yet. So let's look over here at BS. So BS is going to be this line. Here I'm going to count rise over run. So 1, 2, 3, 4, 5, 6. So -6 over -1, 2, 3. So a slope -6 over -3, because I went down it's negative and left it's negative, gives me a slope of +2. So slope of 2 for this segment. And then my last segment is going to have a slope here. Let's calculate. Rise over run. So we're going to rise 2 and run 1, 2, 3, 4. So we went up and to the left, so my slope's going to be -1/2. So just looking for perpendicular lines, we are looking for the angles that form a right angle. So we tried to see if this one formed a right angle, but these are not opposite reciprocals, so they did not. This looks like our next best option. We can conclude that these two are perpendicular because their slopes are opposite reciprocals. So SB or BS has a slope of 2 and BF has a slope of -1/2. So these two are opposite reciprocals, so we know that is our answer. Number 10, line P is parallel to line Q, and line N is a transversal. We have the equation P equals, of line P, y equals 1/4 x plus 3. They want us to find the slope of line Q. So since they're telling us that these lines are parallel, we know that parallel lines have the same slope. So whatever my slope is for line P, it has to be the same slope as line Q. So since my slope in line P is 1/4, then my slope in line Q must also be 1/4. Number 11, we're going to reflect triangle ABC across x equals 1. So I'm going to start by drawing that line of reflection, x equals 1, vertical line. Oh, I almost drew it at -1. Sorry, guys. X equals 1 would be right here, that vertical line. So I am going to go ahead and reflect this across x equals 1. So if I'm reflecting, it's going to flip and land over here across my line of reflection. So A prime, since it's on the line of reflection, A prime is going to land right here on A. So that one is not going to move. It lands on itself. Then B, since B is 2 to the right of my line of reflection, it has to be the same distance to the left. So B prime is going to be 2 to the left of my line of reflection. Then we can do the same thing with C. C is 1, 2, 3 to the right, so it has to be the same distance when it's reflected over here to the left. And I make sure that I label my points. I'm going to draw that triangle. And then I'm going to write down the ordered pair. So we graph the image. There it is. And then we're going to give the coordinates. So the mistake that people make when they write the coordinates is they use the line of reflection. When you write your coordinates, you always start at 0, 0. Start at your origin. So my ordered pair for A prime is at 1, 2. B prime is at -1, 2. And C prime is at -2, 6. So there's your coordinates for your image after the reflection. Number 12, the equation of a line P is given y equals -5x minus 7. They want us to identify the slope of a line, again, parallel to line P. Parallel means same slope. So a line parallel to P would have a slope of m equals -5. Since slope of line P is -5, you're going to use the same slope. Identify the slope of a line perpendicular. Perpendicular again means the slopes are opposite reciprocals. So we'll look at that slope -5, and we are going to flip the fraction. We're going to do the reciprocal of the fraction, and we're going to change the sign. So my slope will be a positive 1/5. We change the sign, it becomes positive. Flip the fraction, reciprocal of the fraction becomes 1/5. Pat believes that the slope of a line parallel to P, so parallel to this line, is -7. Pat is wrong, and explain what mistake is he most likely made, or she, whoever Pat is. What are they doing wrong? So I'm going to say that Pat probably thought that the y-intercept was the slope. So Pat looked at the y-intercept in the equation. So they looked at -7 instead of the slope. And the slope was -5. So we can write down that the number, or the slope, so that Pat doesn't make this mistake again, the slope is the number multiplying with x. So that number that's in front of x is the slope, not the number out here. So he or she, Pat, should have said the slope of the line parallel to P is -5. Okay, because it's going to be the same as the slope there, so -5. Okay, number 13, we're given the figure and we're going to explain why angle EFD is not one of the ways to represent angle 4. So angle EFD is this one, EFD, which is not angle 4. So angle 4 is here. This is not angle 4, and we can explain one of the ways. So let's write that down. EFD does not represent angle 4 because when naming an angle, use points from one side, the vertex, then the other side. Okay, so if we're talking about angle 4, which is what they're going to want us to name next, here's angle 4 that I've highlighted. Okay, when you name angle 4, you use a point from one side, like B, then the vertex, which is right here, E, in the vertex of the angle, and then the other side. So an example of that would be angle BEF. So again, side, then the point in the middle is that vertex, and then a point from the other side. Another way we can name that is angle BEC, again, side, vertex, side. And then we'll just add in a couple more, even though they want two ways, that you can just switch the order and say FEB, and switch the order here and say CEB. But E has to be the number in the middle of the three letters because that is where the vertex of the angle is. Number 14, we are given that F is parallel to G and H is a transversal passing through. Given the pairs of angles below, determine if they're congruent or supplementary. So we will write that down here. So we're first looking at angle 1 and angle 2. Angle 1 and angle 2 are a linear pair. So a linear pair, those angles add up to 180 degrees. Those are supplementary. Those are supplementary angles. Angle 7 and angle 2, their relationship, those are alternate interior angles because they're on alternating sides of the transversal on the inside of the parallel line. So angle 2 and angle 7, we know by that theorem, those are congruent according to our alternate interior angles theorem. Angle 3 and angle 1, those are corresponding angles, and by our corresponding angles theorem, those are also going to be congruent. And then angle 7 and angle 6, those are same side interior or consecutive interior angles. Those add up to 180 degrees according to that theorem. So those are also supplementary. Given that line G is parallel to line H and line H is perpendicular to line J, that's what these mean, just if we need a refresher. This means parallel and this is perpendicular. Okay, so what we're going to do is, given this information, we're going to figure out which one of these three things is true. So it'll be helpful if we draw. So line G is parallel to line H. So I'll draw that. Then we're given that line H is perpendicular to line J. So perpendicular means these lines are going to cross at a 90-degree angle. So that means if this is line J, it's going to form a 90-degree angle with line H because those are perpendicular. So that means that as it continues to go through, these slopes right here are opposite reciprocals, which means these slopes are also opposite reciprocals. G and J also have opposite reciprocals because H and G have the same slope. So this means that G is also perpendicular to line J. So that would be our answer. They also cross here, J and G, at the 90-degree angle. Stephanie measured angle 1 and angle 2 below with a protractor and found that they both measure 90 degrees. She concludes correctly that the lines are perpendicular. So we're going to explain why Stephanie is correct. So Stephanie is correct because the lines are perpendicular because they meet at a right angle. That's the definition of perpendicular lines. They form a right angle, they meet at a right angle. And if Stephanie measured that angle 1 and angle 2 were both 90 degrees, that means that these lines are perpendicular. So what would need to change about the angle measures to make it so the lines would no longer be perpendicular? So what that means is that the angle measures had to be anything but 90 degrees. So if the angle measures were any measure other than 90 degrees, sorry guys. So if the angle measures were any measure other than 90 degrees, the lines would not meet at a right angle. And perpendicular lines meet only at 90-degree angles. So any other measure would no longer make those lines perpendicular. Okay, number 17, we're given this diagram. We're going to define each of the following terms and then choose an example of pair of angles that satisfy the definition. So here we're given S and T are parallel. So I'm going to go ahead and highlight those. S and T are parallel. And then we have this transversal going through right here. Okay, so alternate exterior angles we will define first. Alternate exterior angles lie on opposite sides of the transversal on the outside of the parallel lines. So we're looking for angles that lie on opposite sides of this transversal, which is here in orange, outside of the parallel lines. So an example of that would be angle 4 and angle 7. Alternate exterior. Vertical angles are the angles whose sides form two pairs of opposite rays. Or a little mathematically incorrect way, what I like to say is the angles that are opposite from one another. So if we look back at our figure, we can see two lines, two angles whose pairs of angles formed by opposite rays. That would be this part right here. And vertical angles would be angle 3 and angle 4, because they're opposite from one another. So angle 3 and angle 4. Alternate interior angles are angles that lie on, again, opposite sides of the transversal on the inside, hence the word interior, on the inside of the parallel lines. So we will look on the inside of our parallel lines, opposite sides of the transversal, and we have angle 3 and angle 5. Angle 3 and angle 5 are an example of that. Alternate interior up here. And then same side or consecutive interior angles lie between the two parallel lines and are on the same side of the transversal. So lie between the two parallel lines and are on the same side of the transversal. That would be angle 8 and angle 5. So we have angles 8 and 5. All right, a couple more questions. We are almost done. Number 18. Line P is parallel to line Q, and both are cut by this transversal T. We're going to write an equation that can be used to find the value of x, and then we're going to justify our reason for creating that equation. So I'm going to start by looking at my angles right here, and these are consecutive interior angles or same side interior angles, so those are going to be supplementary. We are going to add those. Set them equal to 180 degrees because those are consecutive interior angles. All right, so those are supplementary. We added them, they're equal to 180. Now we're gonna find the value of x. So I'm gonna go ahead and rewrite that here. And I'm gonna solve for x. So I'm gonna combine like terms. 5x plus x is 6x. Negative 70 plus 10 is negative 60. Then I'm going to add 60 to the other side. 6x is equal to 240. Then when I divide by 6, x is equal to 40. Now I'm going to find the measure of one of the acute angles. So what I'm going to do is I'm going to plug in 40 for an acute angle. Acute angle is an angle that is greater than 0 but less than 90 degrees. So we're looking for an acute angle. So that would be right here at x plus 10. You could plug it in for 2x minus 30, but I think x plus 10 might be a little easier. So x plus 10, and I'm going to replace x with 40, which I found over here. 40 plus 10 is 50. So the acute, one of those acute angles, all of the acute angles, 50 degrees. Just for the record, if anybody did this on their own and you're using this video to check your work, another way you could have created an equation would be to add these two and set them equal to 180 degrees. And your reason for that would be the linear pair postulate, because linear pair, those angles are also supplementary. You would add them, set it equal to 180, solve, and you should get the same answers that we got here. All right, last question, and the most fun question is going to be this proof. where they're giving us that these two lines are parallel and that the measure of angle 3 is 85 degrees. We're going to prove that the measure of angle 6 is 95 degrees. So step 1 is done for us. Step 1 is always going to be what's given to us. Okay, and then when we try to get down to our final step, we're trying to show measure of angle 6 equals 95 degrees. We need to come up with a game plan. So what we have here is 3 different angles that are labeled. So we want to think about what their relationships are in terms of parallel lines. So what we want to think about is corresponding angles, alternate exterior, alternate interior, and same side interior. So linear pairs and vertical angles will also help us out. So based on this right here, these two that are labeled, we know that these have a relationship. Angle 3 and angle 4 are a linear pair. So we can go ahead and come up with an angle measure for 4. And then 4 and 6 have a relationship. Those are alternate interior angles. So we're going to be using that information to help us prove. So for step 2, I'm going to say that angle 3 and angle 4, those angles add and equal to 180 degrees. And my reason for that is our linear pair postulate. So our linear pair postulate says that the angles that form a line, like 3 and 4, add up to 180 degrees. All right, so step 3, I want to find a measure for angle 4. So based on what we said in step 1, we know the measure of angle 3 is 85. So what I'm going to do is I'm going to substitute in 85 for the measure of angle 3. So 85 degrees plus the measure of angle 4 is equal to 180 degrees. That reason is substitution, because I substituted in 85 for angle 3, the measure of angle 3. So now, based on this, I'm able to find the measure of angle 4. If I subtract 85 to both sides, I solve to get the measure of angle 4. So the measure of angle 4 is equal to 180 minus 85, 95 degrees. And your reason for that, you could say that I solved, or I subtracted to both sides. So it's the subtraction property of equality. I'll just write subtraction property because we solved by moving the 85, subtracting 85 to both sides. And so we got measure of angle 4 is 95. Okay, so with that, we know that this is 95. So we want to now bring in angle 6. Angle 4 and angle 6, we know that those two angles are congruent. Those two angles are congruent because they're alternate interior angles. And alternate interior angles, given parallel lines, the theorem says that alternate interior angles are congruent. So it's the alternate interior angles theorem that says they're congruent. And then we're going to use our substitution property again. Since we know the measure of angle 4 is 95, we're going to replace measure of angle 4 with 95. So we know now that the measure of angle 6 is equal to 95 degrees. And that was using substitution. I substituted in 95 right here for the measure of angle 4. So measure of angle 6 has to equal 95. All right, make sure you study that. Good luck on your test.